Hackers and hackerettes, welcome to a new video in our Port Swigger pre-security, I guess we can call it like learning path, or you can call it modules, whatever. So the last video we finished up the networking, and which was the fundamentals to networking. In this video we are going to talk about DNS, and which is the first video in how the web works. So this will be in a new playlist. I'm gonna call it like pre-security, how the web works. So you can keep along and follow these in detail, or like in sequence rather. We're starting off with what is DNS. So DNS, or domain name system, provides a simple way for us to communicate with devices on the internet without remembering complex numbers. Much like every house has a unique address for sending mail directly to it, every computer on the internet has its own unique address to communicate with it, called an IP address. An IP address looks like the following: 4 sets of digits, or octets if you've been watching my networking and networking basics tutorials, or essentially just modules like this one. I do recommend you go to them because networking is important for hackers. And we have like 4 sets of octets of digits ranging from 0 to 255, separated by a period. When you want to visit a website, it's not exactly convenient to remember this complicated set of numbers, and that's where DNS can help. So instead of remembering 1.4.26.10.229, you can remember TryHackMe.com instead, which is pretty cool. So yeah, DNS is essentially like a big map, or a ledger, I guess you would call it. You open up, you're looking for TryHackMe.com. Ah, yes, it's connected to this IP address. Sends it back, and this is what you actually connect to. Domain name system is what DNS stands for. You hit a 3-day streak. You've been crushing it on TryHackMe. Come back tomorrow to keep your streak going. No, I'm staying here today, bro. Alright, let's go to domain hierarchy. So root domain, top level domain, and second level domain. So there you go. The top level domain, or the TLD. A TLD is the most right-hand part of a domain name. So for example, tryhackme.com, TLD is .com. So it is the last thing after the last period in there. There are 2 types of TLD, GTLD, generic top level, and CCTLD, country code top level domain. Historically, a GTLD, or like a generic, was meant to tell the user the domain name's purpose. For example, a .com would be for commercial purposes, .org for an organization, .edu for education, and .gov for government. And a CCTLD was used for geographical purposes. For example, .ca, Canada, .co.uk for sites based in the United Kingdom, and so on. Due to such demand, there is an influx of new GTLDs ranging from .online, .club, .website, .biz, and so many more. I saw .xyz the other day, .xyz, which is funny. For a full list of over 2,000 TLDs, click here. Let's actually take a look. Oh boy. Oh boy. Honestly, these look super cool. I'm going to copy these, and I'm going to store them on my lists. I'm just going to go to cyber, and then I'm going to go to, I'm just going to call it lists, honestly. So in lists, I'm going to just wget this, and then I'm going to move like a few other lists, like most common used lists here as well. So we do have sec lists, for example, in tools. I do have sec lists right here, which is like a comprehensive lists, list of lists, I guess. So it's a GitHub repo that you can get from, or sorry, get remote show origin, and then you can just go to this link right here, which is, well, this is a SSH link, but essentially you can just like copy this and Google, and then it's going to give you the GitHub link, and then on GitHub you can just clone this repo, and there's a lot of lists in there, like passwords, fuzzing, discovery, AI, and LLM testing. So these are like payloads and common passwords, stuff like that, that you can use with different tools. But I'm going to be making like my own list here, which I can use to like do some stuff and keep track of stuff. So we'll be using these when we get to like practical machines. Anyway, I digressed a bit. Second level domain. Taking TryHackMe.com as an example, the .com part is a TLD, or like the top level domain, and TryHackMe is the second level domain. When registering a domain name, the second level domain is limited to 63 characters plus the TLD. I can only use A to Z, 0 to 9, and hyphens. Cannot start or end with hyphens or have consecutive hyphens. Okay. Subdomain. A subdomain sits on the left-hand side of the second level domain using a period to separate it. For example, in the name admin.tryhackme.com, the admin part is the subdomain. A subdomain name has the same creation restrictions as a second level domain, being limited to 63 characters and blah blah blah. You can use a multiple subdomain split with periods to create longer names such as jupiter.servers.tryhackme.com, but the length must be kept to 253 characters or less. There is no limit on the number of subdomains you can create for your domain name. So essentially, for example, I have Michael Yusri, which is my personal website. So this is me and my like portfolio. I also have yoink.michaelyusri.com, which is a subdomain of my main domain, michaelyusri.com. And essentially, I did not have to pay again for yoink.michaelyusri. I just paid for Michael Yusri once, and I can create as many subdomains as I want from this main domain, which I guess is the second level domain, and then the TLD is .com. Okay. So yoink is, if you're interested, essentially it's just the logger. So you can start logging, and then any request that is sent to this URL is going to be shown here with a bunch of information. So what I could do, I could just curl this, and then when I curl it, you can see like the request here and some information. This IP address changes, so I don't care about it being shown right here. So essentially, I just reboot my router, and this IP is going to change. So I don't care much. But you essentially just get a bunch of information here. So I digress a bit here. But the idea is that we can have as many subdomains as we want of a main domain. Okay? And we are here now. So, okay, what is the maximum length of a subdomain? So a subdomain is 250... Wait, the maximum length of a subdomain, 63 characters. Sorry. Leveling up in progress. Thank you. Which of the following characters cannot be used in a subdomain? The underscore. What is the maximum length of a domain name? 256. Or is it 260? What is the maximum length of a domain name? Oh, 253. Sorry. I forgot about that. It's 253 right here. What type of TLD is .co.uk? It is a CC TLD, like a country code or a country specific TLD. Okay, we got everything ready here. Let's go to record types. DNS isn't just for websites though, and multiple types of DNS record exist. We'll go over some of the most common ones that you're likely to come across. A record. These records resolve to IP4 addresses. For example, this address. Now, quadruple A, so AAAA record. These records resolve for an IPv6 address. If you don't know what difference is, you should watch my networking series. CNAME records. These records resolve to another domain name. For example, TryHackMe's online shop has the subdomain store.tryhackme.com, which returns a CNAME record, shops.shopify.com. Another DNS request would then be made to shops to work out the IP address. Yeah. So a CNAME is just another domain that you need to go and identify. And then MX is for mail, for sure. These records resolve to the address of the servers that handle the email for the domain you are trying to query. For example, an MX record response for TryHackMe would look something like alt1.aspmx.l.google.com. These records also come with a priority flag. This tells the client in which order to try the servers. This is perfect for if the main server goes down and email needs to be sent to a backup server. Okay. If you've done any DNS work and setting up of a domain, then these should feel familiar to you. Then you have a TXT record. These are just, you can put whatever you want in there. TXT records have multiple uses, but some common ones can be to list servers that have the authority to send an email on behalf of the domain. This can help in battle against spam and spoofed email. They can also be used to verify ownership of the domain name when signing up for third-party services. So yeah, for example, you sign up for, let's say, Vercel or something like that. We're going to stick with Vercel. Vercel is going to tell you, take this text record and put it on your domain. And the way to do that is you create a new TXT record on your domain, and then you paste in the value that Vercel gave you. And that way Vercel can query, like do a DNS query, and then check that you actually added the correct value in there, and then it's going to make sure that you own the domain. Or you hacked it and you just have access to its DNS, whichever it is. But essentially, it usually means that you do have control over the domain. That means you own it. And this is good enough for them to like give you control over the domain access. So you can easily verify ownership using eTXT stuff. Okay, so as you can see, as the name implies, TXT records are strings of text. What type of record would be used to advise where to send mail? That's an MX. What type of record handles IPv6? That's the quadruple A. Right, awesome stuff. Let's go to making a request. What happens when you make a DNS request? Now, if you don't know what DNS stands for, domain name system, right here. So keep that in mind because we're going to be dealing with DNS a lot in our hacking career. When you request a domain name, your computer first checks its local cache to see if you've previously looked up the address recently. If not, a request to your recursive DNS server will be made. Now, if you don't know what this is, so DNS has a cache similar to ARP. Again, if you haven't watched that, it's in my networking tutorial. I keep looping back to this because it's very important. But the same way you have an ARP cache, you do have a DNS cache. And then here's a good tip for you. If you're on Windows, and sorry, type drivers, not hosts, and then you can go to etc, and then the hosts file. This is your local machine. You can call it cache, or you can call it like DNS registry. But if you open up this file, you need to be administrator to do that. And then you enter a domain name, say for example, google.com, and then enter like an IP address. This is gonna make, whenever you type google.com in your browser, it's gonna actually resolve to the IP address that you input, and it's gonna open that IP address instead of whatever Google's IP address is. So you could like play a prank on your friends. You can just map google.com to like a local some kind of server or web server, or using the local IP address, and from that you could actually like open up, you have been hacked, or some kind of like funny stuff like that. Just please make it a harmless prank. And then you're like the google.com, whenever they open it, they're gonna look like, oh, you've been hacked, and they're gonna freak out and all kind of stuff. All you did is just like create a fake page, and then you just edit the hosts file in here. So if you're on Windows, we can do that. Or if you are on Mac, I think Mac is the same as Linux. I'm actually going to talk about Linux because I think Mac is the same. But if we edit etc hosts, then you can see it is kind of the same thing. You do have an IP address here, so you give the IP address that you want it to resolve to, and then the domain name. So localhost here resolves to 127.0.0.1. This is why when you type localhost, it is the same as typing this IP address. So for example, if I wanted to add Google, what I would do, you can see I'm changing a read-only file, but I'm not really going to save this. So I could type, for example, like 192.168.1.4, which would be like a local IP, or I could still do 127.0.0.1 and then type google.com here. So whenever they go to google.com, actually going to resolve locally, and then you can handle that on your local web server to run the prank that I was talking about. I think on Mac it would be the same. If not, you can just Google it, because I actually don't know how it is on Mac. Okay, a bit of digression there. Let's go back to our number 2 here. A recursive DNS server is usually provided by your ISP, but you can also choose your own. This server also has a local cache of recently looked up domain names. If a result is found locally, this is sent back to your computer, and your request ends here. This is the most common and popular for heavy requested services such as Google, Facebook, Twitter. If the request cannot be found locally, a journey begins to find the correct answer, starting with the internet's root DNS servers. So you can see we have a PC here that asks for a recursive DNS server, root DNS server, authoritative, and then it goes back to your PC. Okay. The root servers act as the DNS backbone of the internet. Their job is to redirect you to the correct top-level domain server, depending on your request. If, for example, you request www.tryhackme.com, the root server will recognize the top-level domain of .com and refer you to the correct TLD server that deals with .com addresses. Okay. The TLD server holds records for where to find the authoritative server to answer the DNS request. The authoritative server is often also known as the name server for the domain. For example, the name server for TryHackMe is kip.ns.cloudflare.com. NS stands for name server here. And then UMA. So kip and UMA. Usually Cloudflare give like literal names, like human names, to their name servers. You'll often find multiple name servers for a domain name to act as a backup in case one goes down. Correct. An authoritative DNS server is the server that is responsible for storing the DNS records for a particular domain name and where any updates to your domain name, DNS, records would be made. Depending on the record type, the DNS record is then sent back to the recursive DNS server, where a local copy will be cached for future requests, and then relayed back to the original client that made the request. DNS records all come with a TTL, or a time to live value. This value is a number represented in seconds that the response should be saved for locally until you have to look it up again. Caching saves on having to make a DNS request every time you communicate with a server. We have seen TTL in a lot of places before. So they will be used like across multiple things in networking. And in this case, the DNS is kind of like the cache duration for like a cached asset, for example, on like websites and stuff like that. You can tell the browser for how long to cache this for. And it is literally just the same concept here. So the authoritative server is going to tell you, save this domain for this amount of seconds until you have to request it again. And once the TTL is over, you then have to come back to me and ask me again for the domain. This is done so that whenever domains change IP addresses, so for example, my domain michaelyostre.com could now live on a specific server, but then once it's like I just decided to change my hosting to a different like provider or something, the IP address of the server, of course, is going to change. So that way, when I go back to my DNS and then change the server that is hosting michaelyostre.com, it's going to change and reflect on people that have the domain name cached. And it's not going to stay forever at the old server. Okay. What field specifies how long a DNS record should be cached for? We've been spamming that. It's TTL. What type of DNS server is usually provided by your ISP? So if you want to see what this is, it is a recursive. If you don't remember, you can come back here and you can see that a recursive DNS server is usually provided by your ISP. There it is. What type of server holds all the records for a domain? It is called authoritative. I hope I wrote it correct. Yeah, I did. Cool. I don't know what this leveling up in progress is. I'm going to give it a refresh. All right. So we're done with making a request. Let's get to practical. Using the website on the right, we can build requests to make DNS queries and view the results. The website will also show you the command you need to run on your own computer if you wish to make requests yourself. What is the CNAME of shop.website.thm? And you can see the CNAME. Wait, what? Oh, it's we need to just write shop in here. Okay. So what? Oh, CNAME. Okay, so the CNAME shops.myshopify.com. Copy this. What is the value of the txt record of website.thm? Okay. So the way to do that is we just do text and then the text record of website.thm. So I don't need to add any subdomain. There it is. Boom. What is the numerical priority value for the MX record? Let's do MX. And it looks like would that be 53? No. For the MX record, what is it going to tell us? Set the DNS and keep the subdomain field blank. This is what I did. Is the exchanger 30? Is that it? Oh yeah, okay. This is it. I actually did not know that. What is the IP address of the A record of www.website.com? So you just need to add www. And it is 10.10.10.10. Boom. All right, we got it. Great work, 47. Room completed. We are farming some values over here. And we got our DNS in detail. Okay. This is it for this video. I'm trying to keep these as short as possible as we go through the tasks together. So that you're not bored and you're actually looking. So if you're looking for something specific, you would actually find it in a video and that's it. But if you don't like these formats and you would want like the entire thing in one video, let me know. Maybe I could like combine these videos into like a separate video. So we could just skim through it and go like speed run it essentially. But yeah, thank you for watching this video. Let me know in the comments below if you like these videos or not. My channel is new and all I'm trying to do here is to give as much information as possible to the community because I myself learned from the community. I learned from free YouTube videos. I learned from Stack Overflow and other free sources on the internet. So all I'm trying to do here is to give back to the community that I took from. So let me know if you really like these videos. If you don't, give me comments below. Constructive criticism is always welcome. Let me know in like any way, shape or form that what you liked, what you don't like about these videos, and I'll do my best to make them better. So subscribe to stay in tune, and in the next video we are gonna have HTTP in detail. Thank you for watching and I'll see you then. See ya.